Hello students. So last time I explained you how to balance a chemical equation. Today I will explain you what are the various types of chemical reactions. The various reactions have been classified into various groups for easier understanding and knowing their properties. Like first group is called combination reaction. As the name suggests, combination means adding, joining. So when two or more reactants combine and form a single product, then that reaction is called a combination reaction. The reactants can be an element, it can be a compound. Let us see the first example. Calcium oxide. Calcium oxide. You can see here, this is calcium oxide is added to water. So when we add calcium oxide to water and stir it, it forms calcium hydroxide, which is called slaked lime. This is slaked lime. So this is an aqueous solution, and when this solution is used for whitewashing the walls appears wet, but gradually it reacts with carbon dioxide, and calcium hydroxide plus carbon dioxide forms calcium carbonate and water. Now this water will give you the feeling that the wall is wet, but calcium carbonate will make the wall shine, and gradually as the water evaporates, the walls will shine. So it is due to calcium carbonate. How? First we have taken calcium oxide and we have dissolved in water. It forms calcium hydroxide. So two reactants are joining and forming a single product, calcium hydroxide. In bracket, S means this was in the solid state, this is in the liquid state. Aqueous means this is dissolved in water. So now let us see other examples. When we mix hydrogen gas and chlorine gas, you are getting HCl, hydrochloride gas. So here also you can see the two reactants are forming a single product. In bracket we write the state of the reactant or compound. Carbon, when we burn in oxygen, this is solid, this is oxygen, you get carbon dioxide. Similarly, ammonia and HCl gases, when mixed, will form ammonium chloride, which is solid. Carbon monoxide gas reacts with oxygen and forms carbon dioxide. Sulfur dioxide, when heated with oxygen, will form sulfur trioxide. 3 means tri. So all these examples show that when there are two or more, in this case I have written 2, they can be also 3. When there are 2 or 3 reactants or 2 or more reactants to get a single product, these are called combination reaction. Okay, so we will move to next slide. Now next type of reaction is called decomposition reaction. Now as the name suggests, this is opposite of combination. Here our reactant is a single compound, and when we give some energy to it, it can be in the form of heat, it can be in the form of electricity, it can be in the form of sunlight, etc. Then it decomposes, it breaks into simpler parts, smaller parts. Like example, I have taken ferrous sulfate, which is solid green crystal. When I heat, I will get Fe2O3, ferric oxide, because here the valency of ion is 3. You can say O3 by, we cross multiply. So this is ferric oxide, which is brown in color, and sulfur dioxide and sulfur trioxide gases are emitted. So this will give us the feeling of sulfur, and this is ferric oxide. So you can see the change in color, and this is solid and these are gases, only this will remain. So one single reactant has formed 3 products. Second reaction, when we heat calcium carbonate, limestone, it will form calcium oxide and carbon dioxide. The states are given, you know this is gas and these two are solid. Now you will see in decomposition I have to supply energy. I am supplying here energy in the form of heat. when energy is supplied in the form of heat, such reactions are called thermal decomposition reactions. Now when potassium chlorate KClO3 is in solid form, is heated, and in bracket I have written MnO2. So this in bracket when we write means this is a catalyst. Catalyst will make this reaction fast. If you heat without catalyst, reaction will take place but at a slower pace. So potassium chlorate when heated is forming two products, potassium chloride and oxygen. So this reaction as such is used in laboratory preparation of oxygen. The next example, lead nitrate, which is colorless. When we are heating it, it is forming lead oxide, which is yellow in color, and NO2 gas, which is in the form of which appears like brown fumes, and oxygen gas is also given out. So as such, you may think that I will only learn one or two examples of each type and be able to answer the question. But sometimes they ask the question, give action of heat on lead nitrate, give action of heat on potassium chlorate. So you can't miss any equation or any reaction that has been given in the textbook. Is it alright? So now then we'll go to next. Now here, instead of heat, I am using electricity as source of energy. Now electricity is DC. DC means current will flow in the same direction. Either the current will flow in this direction or the current will flow in this direction. When the current flows in this direction, means this is positive and this is negative. This is positive and this is negative. So I have to use DC supply so that my electrodes remain with the same polarity. So when electricity is passed through water, it gets decomposed into hydrogen and oxygen. So water is made up of two elements, hydrogen and oxygen. Now it has decomposed. So a single product is forming two elements. So this is a decomposition and it is by electricity. So we call it electrolytic decomposition, and this process is called electrolysis. So what we'll say, we are doing electrolysis of water. So when we do electrolysis of water, you get hydrogen and oxygen gas. Similarly, now let us do electrolysis of aluminium oxide. You see, valence of aluminium is 3, so 3 has come here. This is in the liquid state, but this aluminium oxide is solid state, so means we have to heat it and melt it. So we are taking aluminium oxide in the liquid form, and when we pass electricity through it, so aluminium is positive, so it will go towards the negative, and oxygen is negative, will get collected towards the positive electrode. So that is why my electrodes have to be at the same polarity all the time. So I will get aluminium and oxygen. These numbers are coming by balancing. For simple equation, you can do balancing without that ABCD, but orally, mentally. Okay. Now I am taking sunlight as a source of energy. So when silver chloride is placed where there is a sunlight falling on it, then it will get decomposed into silver and chlorine. Silver is in grey in color and chlorine is yellowish green. And so silver chloride, which was white solid, has formed grey, and this. So this was used in photography when films were there, which have become outdated now. So at that time we were using this. Similarly, in silver bromide, this is pale yellow in color. When sunlight falls on it, it forms silver and bromine. Now, so as you have seen, for all this decomposition reaction, we have to supply the energy. Energy can be in the form of heat, electricity, sunlight, etc. So all reactions of decomposition are of endothermic reaction. Endothermic means reactions in which heat is absorbed, because we are giving this heat. So they are endothermic reaction. Now similarly, when the food we eat, they also get decomposed and form simpler products. So decomposition reaction is taking place in our body also. Now we'll go to next type of reaction called displacement reaction. Now displacement reaction means when some element replaces other element from a compound. Like you see this example, it will become more clear. This is iron, ferrous in solid, is added to liquid copper sulfate, aqueous solution of copper sulfate. So this is also metal, this is also metal. But iron is more reactive than copper. So iron will attract the sulfate ions with a stronger force. So sulfate will move towards the iron and copper will get separated. So I am getting ferrous sulfate and copper. So what we say, that iron is more reactive than copper. So if iron replaces copper, iron displaces copper. So this is a displacement reaction. Okay. Now in the same manner, zinc and copper sulfate will also show similar reaction. Zinc is silver in white, it will form zinc sulfate as an aqueous solution, and copper, which is reddish brown in color. So this will get separated. Is it okay? So these are called displacement reaction. One metal is replacing other metal. Now another example, copper is as such least, one of the least reactive. So iron, zinc, everything. But copper is more reactive compared to silver and gold. So if I take silver nitrate and put copper strip in it, it will displace silver. So we will get copper nitrate blue solution and grayish white silver. So copper, which is reddish in brown, will react with silver nitrate aqueous solution, and copper will displace silver and form copper nitrate. Is it alright? So now next reaction, iron and HCl. So iron, hydrogen is in the, as I told you last time, that first we write metals are positive and then negative. So here hydrogen is in the positive ion and chloride is a negative ion. So iron has got more affinity to chlorine, so it will form ferrous chloride and hydrogen gas will be liberated. Okay. Now, in the same manner, sodium and water. Water you can consider as HOH. So it will form sodium hydroxide and H will form hydrogen gas. You have to do balancing. So sodium reacts with water, forming sodium hydroxide, which is solution, and hydrogen gas is liberated. Now, so far we have seen metals replacing another metal or other positive ion. So now same thing applies also to negative. Like if I take chlorine gas and pass in potassium iodide solution, this is solution, then chlorine is more reactive than iodide. Chlorine is more reactive than iodide, so it will form potassium chloride and iodine will get displaced. So I will get solid iodine and potassium chloride. So now you see, this is an example of negative. Now iron oxide is heated with aluminium. Iron oxide heated with aluminium. Aluminium is more reactive than iron, so aluminium will come here. I will get aluminium oxide and iron. Now this is very important reaction, because when this reaction takes place, good amount of energy is liberated. The energy liberated is so large that this iron which has got formed, melts, and this liquid iron we pour wherever we have cracks in our metallic parts, in bridges, in other machinery. When there are cracks, so we will make a funnel type thing. So this is the funnel, and here is the bridge. Okay, and here on the surface there is a crack, and this has been placed just above the crack, and so we will carry out the reaction here. So we will carry out the reaction here. Molten iron will fall, and it will fall in the crack of the iron bridge or iron machinery, and it will fill that, and then it will become solid. So this method of welding iron is called thermite welding. It's called thermite welding. So sometimes they ask the question in the form that what is thermite welding, or give equation of thermite welding. What is the use of thermite welding? So it is used to fill the cracks or holes in the machinery which have got formed. Now we'll go to double displacement reaction. As the name suggests, double displacement means now both the ions interchange their positions. So each reactant is having two ions, silver nitrate, sodium chloride. So they will interchange. It will form silver chloride and sodium nitrate. So this positive will take this negative, and this positive will take this negative. So all these reactions are like this: barium sulfate, sodium chloride, copper sulfide, and H2 and sulfuric acid. Now in this reaction, many times in the product, one thing is insoluble. Here, like I have written sodium chloride, I have written as solid, and arrow down means it will go at the bottom of the solution, and you can see the solid particles at the bottom. It has got color, like barium sulfate is also a so this they are called precipitate. They are called so barium sulfate is a precipitate. Here copper sulfide is a precipitate. This is black in color. Okay, and here aluminum chloride and ammonium hydroxide. So we got aluminum hydroxide and ammonium chloride. Now this is also white precipitate, aluminum hydroxide and ammonium chloride. This is an aqueous solution. Now sodium hydroxide plus HCl will form sodium chloride and water. This is alkali, this is acid. So acid plus base, you can say alkali, you can say form salt and water, salt and water. This is also solution, this is water. So there is no precipitate. So it is not that always there will be a precipitate. Here there is no precipitate. Okay. So in the reaction in which precipitate is formed, they are called precipitation reaction. I have given more example. Lead nitrate plus potassium iodide will form lead iodide plus potassium nitrate. So this is aqueous solution. This is yellow color precipitate. Is it all right? Now we'll go to these are exothermic, endothermic. Exothermic means where heat energy is given out, liberated. Endothermic means where heat energy is absorbed, or it requires heat energy for the reaction to take place. This we have I told you that all decomposition reactions are endothermic. Photosynthesis in plants also requires sunlight energy. So that is also an endothermic reaction. Electrolysis of water, all this which we have studied in the decomposition, they are endothermic reaction. So let us see exothermic. This to know when I burn carbon, coal with air, oxygen, you get carbon dioxide. Heat is liberated. Methane, if we burn carbon dioxide and water. Any compound of carbon and hydrogen will form carbon dioxide and water. During respiration, our glucose is C16H12O6. So carbon and hydrogen, so will form carbon dioxide and water. And energy is liberated, and with this energy we are doing our work and keeping our body warm. So these are all exothermic reactions. Burning of magnesium, which we have studied, forms magnesium oxide. It also is an exothermic reaction. Okay. Now we come to very important topic, oxidation and reduction reaction. First, what is oxidation? Oxidation is a reaction in which oxidation, so means oxygen is added. So oxidation has come from oxygen, so reaction in which oxygen is added, and opposite of oxygen is water or hydrogen is removed. So this you should learn. Oxidation means oxygen is added or hydrogen is removed. No, so reduction is opposite of oxidation. So here I told oxygen is added, so here I will say oxygen is removed. So opposite of this. Hydrogen is removed, so hydrogen is added. So this you should learn, this you should never forget. Oxidation means chemical reaction in which oxygen is added, hydrogen is removed. Now if oxidation and reduction normally occurs together, so they are called redox reaction. Redox means reduction, OX stands for oxidation. Now the substances, now for oxidation is to be added. So the substance which gives oxygen are called oxidizing agent, or hydrogen is removed. So substances which removes hydrogen are oxidizing agent. So oxidizing agents are those which gives oxygen or removes hydrogen. Reducing agents would be opposite, which will remove oxygen or give hydrogen. They are reducing agents. Now these things will become clear with the various examples that I am explaining you. Copper oxide, hydrogen is passed over copper oxide, heated copper oxide. So what will happen? This oxygen goes with hydrogen, will form copper and copper. So copper oxide has formed copper. So what has happened to copper oxide? It has lost oxygen. So losing oxygen is reduction. So copper oxide has got reduced to copper, and hydrogen has taken this oxygen. So the gain of oxygen by hydrogen, so this has got oxidized. So I have written here. So oxidizes hydrogen, reduces copper oxide. Now whichever substance gets oxidized, it is a reducing agent. Hydrogen has got oxidized to water. So what hydrogen has taken? Hydrogen remove oxygen from here, so it is a reducing agent. So reducing agent is hydrogen. Copper oxide has got reduced, so it is an oxidizing agent. So oxidizing is copper oxide. Why? See what copper oxide has done? It has supplied oxygen. So any substance that supplies oxygen is a oxidizing agent. So copper oxide supplies oxygen, so it is an oxidizing agent. So but when it is supplying oxygen, it itself will get reduced. So just learn this, that any oxidizing agent, what will happen to it? It will get reduced. Any reducing agent will get oxidized. So if you know any one thing, you can say the other. If I say substance X is getting oxidized, so when substance X is getting oxidized, so what does it mean? Means it is a reducing agent. Now so see another example. H2S plus chlorine is forming this. Now what will happen to H2S? See, here this is H2S, and here what we are having? Sulfur. So hydrogen has got removed. So removal of hydrogen is oxidizing. So H2S has got oxidized to sulfur. H2S has got oxidized to substance, to sulfur. The written substance oxidizes H2S. And what has happened to chlorine? Hydrogen has got added to it. Addition of, what is addition of hydrogen? Addition of hydrogen is reduction. So chlorine has got reduced to HCl. So substance is reduced is chlorine. Now this has got oxidized. So as this has got oxidized, so it is a reducing agent. See, chlorine has got reduced, so it is an oxidizing agent. Is it all right? So this is very important point you should learn, that oxidizing agent will himself will get reduced. Reducing agent will get oxidized. Another reaction. manganese dioxide plus HCl is forming manganese chloride, chlorine and water. Now to compare manganese dioxide, what has happened to the oxygen? It has got removed. So removal of oxygen is reduced. So manganese dioxide has got reduced. So manganese dioxide is losing oxygen, so it has got reduced to manganese dichloride. And it has supplied oxygen, so it is an oxidizing agent. MnO2 is supplying oxygen, so it is an oxidizing agent. Now you see HCl, hydrogen is getting removed. Hydrogen is getting removed. So removal of hydrogen is oxidized. So HCl is getting oxidized to chlorine. Is it alright? So HCl is supplying hydrogen, so it is a reducing agent, isn't it? And it is itself getting oxidized. Now, nowadays, instead of explaining in terms of oxygen and hydrogen, we are saying in general now, addition of non-metallic element. Addition of, like oxygen is a non-metallic, or removal of metallic is oxidation, and its opposite is non-metallic. Like, okay, now when copper is heated in air, it will form copper oxide. So oxygen is getting added to copper. So what is happening to copper? It is getting oxidized. What is happening to oxygen? It is getting reduced. One substance gets oxidized, other will get reduced. H2S plus SO2 forms water and sulfur. Now what happens to H2S? It is forming sulfur. So hydrogen is getting removed. When hydrogen gets removed, it is an which type of reaction? When hydrogen is getting removed, it is an oxidation. So this is getting, H2 is getting oxidized to sulfur, and SO2 has supplied that oxygen, so SO2 has got reduced. So, okay, so sulfur dioxide is getting reduced, this is getting reduced because it is supplying. So as this is getting reduced, so it is an oxidizing agent, it is supplying oxygen. I hope you have understood. Now then we go to its practical application. We have got two major practical applications. One is corrosion of metals and other is rancidity of food. First let us understand corrosion of metals. As the word corrosion of metals means the metal is getting you can say destroyed. Okay, its appearance and properties. Like iron, you know, iron forms rust, and then the rust falls down. Then the new surface of iron gets exposed. It will rust, fall down. Gradually, the material becomes thin and thin, and finally, with the load, it may break also. So that is why many bridges they break after many years. So that is why, so that to increase their life, we should try to keep them protected, that rusting should not take place. Otherwise, due to rusting, huge amount of money is lost, because we may have to discard after some time. So iron and oxygen from air with some water moisture present, therefore rusting takes place when there is a moisture. So in places which are dry, their rusting will not take place. But places which are in coastal areas, there is a good amount of moisture, so rusting takes place. And rust is nothing but ferric oxide and some molecules of water. So this is one about rusting of iron. Similarly, silver, you might have seen that silver ornaments, they become black. They become black because silver with hydrogen sulfide present in air in a very, very small quantity, or sometimes it is present, it will form silver sulfide, which is black in color. Similarly, copper also gets coated with green color. That green color is copper carbonate and copper hydroxide. So due to, so we say basic copper carbonate. So copper gets green in color due to basic copper carbonate. Aluminium vessels, if you go to shop, you will find it shining, but when you use at home, you will find that its shining has gone because it has formed aluminium oxide. But in case of aluminium, good thing is that aluminium oxide adheres to the surface of aluminium. So we say it forms a protective layer. Now aluminium below it does not get oxidized. So only shining will go and material thickness will remain same. As in contrast to iron. Iron forms soft and flaky substance, so it gets removed, so its lower layer also gets rusted. So this is about now how to prevent this, especially of iron, how to prevent rusting. You know, we have to do painting. Then we have got a galvanizing method, means making a thin layer of zinc on the top of aluminium, on the top of iron. Then there is a process called cathodic protection, means making it negative and some other material positive and joining them so that now it will not corrode, but positive material will get corroded. So there are these are the important methods of preventing rusting of iron. Okay. Now we'll go to rancidity. Now this is for food. You might have seen when the food after some time, after a day or so, it loses its taste and it starts giving foul smell. So that is due to rancidity. What has happened? The food has got oxidized from oxygen in the air, especially if it is prepared in oils and fats. So this oxidation of food is called rancidity, and you will come to know because of the unpleasant smell and taste. So this also can be minimized by few methods. You know already this method because your mother might be using it. By addition of antioxidant, and if you add antioxidant, then food will not get oxidized. So the antioxidant normally used are BHA, butylated hydroxyanisole, and BHT, butylated hydroxytoluene. So when they are added to fats and soil, then food will not get oxidized and these substances will get oxidized. Is it okay? Then this packing food in nitrogen, like potato chips or other such food stuff, are packed in packets. Now those packets are containing nitrogen and not oxygen, so they can remain there for a longer duration of time because there is no oxygen, so no oxidation will take place. But as soon as you break that packet, then oxygen air will enter and now it will get spoiled. So that is why they say so far it is in the packet, it will not get spoiled because it is having nitrogen. Then you know we are keeping the thing in refrigerator. In refrigerator, oxidation becomes very slow. Or you can store in airtight containers away from light. So you are having away from light and airtight containers, so there is no much fresh oxygen it is getting, and its temperature is also not high. It is not getting energy, so the reaction becomes a bit slower. So these are the common methods that we use to prevent rancidity. Is it okay? I hope. Now this is a fully theoretical chapter, so you have to learn the various points and practice writing the equations. Okay? So please, if you like this chapter and my explanation, you can subscribe to the channel, like it and press the bell icon so that you will get notified when I am putting the next video. Thank you.